Hello and welcome. I just wanted to make a video about how I do certain things in Blender. Just showcasing my workflow, maybe make it a little bit of a tutorial. We will see. I'm not sure about how I'm going to edit or not edit this video. Maybe it will be one uncut take, maybe not. We will see. I thought it would be an interesting video idea to show how I would go about making a path in Blender, especially looking at fences. And I think I have quite a good way to procedurally generate fences around your path, so you don't have to really care about that step too much, so it's easy to make changes later to adapt existing paths just to make iterations quickly and all that. So this will involve geometry nodes and some more advanced, maybe not really intuitive things for first-time Blender users. If you're a first-time Blender user, you probably don't even know what geometry nodes are, but we will get into that. All right, paths. So you may think of a path as like something like a line that has a certain width, you might say. So like, let's make a quick demonstration. Something like this maybe. So you could do this by using a curve and extending the path, rotating the handles so it like goes in the right direction. And this is something you can do. There's nothing really wrong with this way of doing it, but I would do it differently simply because I feel like paths in theme parks rarely work like this. I think paths are often like everywhere, whereas where they still have space left. So like paths don't connect in like these like paths usually aren't just like these long snake-like line-like sections that are joined together by intersections or plazas, so not really like you would do it in Planet Coaster, for example, but more like you have a huge space, and in that space you have rides, you have planters, you have maybe water features or something, and all that space that is taken up by those things, that's all the areas where you have no paths. So I would do it differently. I would either make that huge plane and then cut all the areas out of it that aren't your path, or I would use a plane, like a plane like this, and just model the path. So that allows you to maybe also do stuff like this, making like changes in path width and like intersections like this. And then you could like could like join up these two paths here again. And merge these 2 points, because I extruded this edge and just moved it over here. So this point from this edge and this point from this edge are 2 different points that are overlapping. So these edges, so like the top edge of this face and the bottom edge of this face, aren't connected. So by pressing A you select everything, and by pressing M you can merge vertices by distance, and that allows you to make this as one thing. And you could do the same here. You could also just highlight all these and press F to fill it. I think I'm just going to extrude some paths here, maybe subdivide this face a little, make it a bit less, make this opening here in the middle a little less rectangular. Maybe that's a nice spot for a tree to go later or something. I'm just pressing G by the way to move these stuffs and pressing Ctrl to snap to the grid. Maybe like this, and maybe let's say there's, I don't know, maybe make this a little less wide. So it's just 2 meters, so like one of these boxes is like 1 by 1 meters large, so you have an idea of how big this is. And maybe extend it further and raise it up. And this could be some kind of ramp. So move this here, move this maybe here. Rotate these 2 so it faces like that way, maybe like this instead. We make it a bit wider again. Maybe 3 meters was good enough. Yeah, something like this. Now I would say this area right here looks fine in terms of how smooth it is, but this doesn't, simply because you can see how we have these sharp edges. And while I think this looks fine-ish, it could look significantly better. Maybe just make this a bit wider, just to fit with the overall. Maybe extend this out a bit again. Just we have a few more intersections going on. Where was I? Yeah, smoothness. So what I usually do is just add a modifier, and that modifier is a subdivision surface modifier, and that makes everything a little smoother. Now there's something fishy going on here. Let me just apply merge by distance. Why is this remaining? It's supposed to look like this. It does not make much sense. It's simply because if I go into this view, just quickly delete this face. Maybe merge by distance again. No. Why do such things only happen on camera? Let me just delete all of these. Maybe that will make enough of a difference. Yeah, that does what I expected here. So let's just quickly recreate this bit. You can see how this already creates smooth transition, not only towards like this direction, but also from here to there. Like we have like this point that is raised up. And that just makes it look much better overall, but you can still see these harsh edges here. So we can select it and shade smooth, and now it's smooth. And we can increase how smooth it is by increasing this value right here. And if we increase it by 1, we can see that this is what happens. So all the faces we had get divided into smaller faces, and the first subdivision looks like this, so our input mesh looks like this, and the first subdivision looks like this, and then if we increase this, it gets smoother and smoother, but in our case I think 2 is more than enough actually. Okay, so now we have a path, but since this video is about fences, let's check out how that works. Alright, adding a geometry nodes now as modifier, you can just click new, and that will add a new node tree to that modifier. And then we can go into geometry nodes. And here we have the input and the output. And geometry nodes is basically a modifier like every other modifier, except you can program it yourself. And we are just going to do exactly that. We are going to make a modifier that can generate a fence around a path. So let's think about what we want. We want the outer edges of this mesh as a fence. So we don't want any fences anywhere else, we just want it around the outer edges. So let's first find a way to isolate those outer edges. Oh no, let's do the second step first. That is actually more intuitive. So using that outer edge as, or rather an edge in general, to generate something else, we can use the mesh to curve node. And if I just put this in here, you can see all the faces go away because the faces are thrown away. All what Blender does is now taking the edges and turning them into curves. And the reason we want to do that is because with curves we can do a lot more cool things. For example, we can use a curve and turn it back into a mesh. Now this does not change anything at first, but it's something really important is happening here, because we can use a profile curve to use for the mesh generation. And that profile curve can just be literally any type of curve. We could use like this curve, for example. So I think I deleted it, or rather I deleted the contents in that node, so maybe it's like add another curve. So I can explain what happens. How do I want to do this? I think I'm just going to showcase what it looks like with a curve primitive at first. So curve primitive and geometry nodes are like nodes that generate a curve that can be defined by simple values. So a curve circle has two generation modes. You can like use points, and I'm not sure how that works. I never use points, but radius is more intuitive. You can choose a radius. Plug this in the output so we can see what happens. You can choose a radius. So in this case, radius is 1 meter, so the diameter is 2 meters. And we can have a resolution, and 32 is just the default number. And if we scroll in a little bit, we can see that the curve isn't actually round. It's consists of a bunch of straight segments. And exactly, yeah, that's the question. Is it 32 segments or are there 32 points? I think it's 32 points, or is that identical? Are there more segments or are there more points than segments? I'm not sure actually. But we can reduce this to something more noticeable, like 5. And you can see what this does. Now we could plug this curved circle into the profile curve, and suddenly we get another mesh. And it looks really stupid because this is actually far from what we want. I would say let's reduce the radius to like maybe something very small, so it has like 4 centimeter diameter. I think 4 centimeters. Yeah, 4 centimeters maybe a little small. Let's do like 6 centimeter diameter. And let's say we only want that on the outer edges. I think this is a good point. Oh no, I forgot to show you what this looks like with like custom-made curves. I can plug this in here, and you can see this shape that is defined here. Is what is used to generate curves. So if I like add more here, you can see how this reacts to it. You can do cool visuals like this as well. It's not what feature is intended for, but like everything is possible. But we do not want this Bezier curve. In fact, I can delete it. I just used it. I wanted to use it for this showcase. And let's go back into the geometry nodes modifier. Delete this node. We want this to be like this thick, I'd say. And use this as a railing. So I want to stack like 1 or 2 on top of each other and have like posts in between in consistent intervals, so we have like a railing or a fence or something. And since I already said like we don't want any railings in the middle, we just want to isolate the outside. And there are a bunch of ways to do this. Like there's one way that isolates the outside, but there are many ways to just feed that outside into this mesh to curve and curve to mesh setup. I think what is easiest to understand is separate geometry. So what separate geometry does is it takes the geometry input and has a selection and an inverted selection output, and it has this selection input. So there's like you can put something in that identifies what of the geometry you put in you want to select, and then you can output that selected or the inverted selection to some other node. So let's just feed the outer edges to this setup right down here. So what we first want to do, we want to use edges instead of points. And I think we need some other things right here. We want to read from our mesh, and we want to read, I think, face neighbors. Was it edge neighbors? I think it was edge neighbors, actually. Yes. So what edge neighbors does, it outputs how many faces an edge is connected to. So if you look here, we can see that we have 9,000 edges at the moment. That's because each edge is turned into like 6 other edges plus 2 times the VCaps in the end. So we have like 18 edges per like beam right here, and that adds up really quickly. So if I just plug this into the output, you can see that the edges are actually only 504 edges. Yeah, and what we can do with the face count, we can, I forgot already if I just mentioned this, but what we face count edge neighbors node does is outputs the number of faces an edge is connected to. So if we go into this wireframe view, you can see that like this edge right here is connected to this face and this face, and this edge is connected to this face and this face. So most of these faces have 2 faces that are connected to them, but the outside edges only have 1 face, and that's something we can take advantage of. We can use a math node set to compare to check if the face count value for any particular edge is 1, and this epsilon value means that how far away from the desired value the input value can be to still be considered as true. So we want exactly 1 edge, or 1 face per edge, and if I put this into the selection, you will see that all the internal edges disappear. Now if we connect that back up to this setup and go to this view, you can see that we now have basically a line going around our path. Now the next question might be, okay, that is all kind of good, but how do we get our path object back? Because what we do here, we feed the path into this node and do something with that, but the initial information is thrown away basically. So what we do is we add a join geometry node to join the output of this back up with this. And now we have our path with a small railing going around it. Now this railing, like when I set these values down here, I imagined this to be like something you hold onto, and obviously you wouldn't want that to be on the bottom of the path. Like who kneels down to just, you get what I mean. This does not make sense. It does not make sense to have something, to have a railing of this size at the bottom right here. So we want to move it up, and we can just do that by using a transform node. And I'm going to put it here because that makes things easier later. And we can now move it up by like maybe half a meter. It's fine. So it's still really low. I would ideally want it at about 80 centimeters maybe. Maybe that's a little low even, maybe like 1 meter. And we can just use another joint geometry node to duplicate the output here. So I can just right click and press duplicate and feed the original version of this that did not get transformed in there as well. But my idea is that we use two railing beams so that it's not that easy to fall in between. So like maybe this is raised up and you don't want any of your guests to fall through. Maybe this is the way to go. So we have these railings. We can duplicate this to make a curb or something similar. Feed this in here and this into the joint geometry, and make this bottom curve circle larger. So maybe like this is good enough, and maybe make it square. So I input 4, a resolution of 4 to make it perfectly square. You can see that the circle is oriented like this. So what we can do is we can take another transform node, put this here, and this moves it up. We don't want to move it up. Also, you may have noticed this was moved up and that had this effect. You may wonder like, why is it moving that way? Why is it distorting? Why isn't it moving all in one direction? And why is the direction not up if we used Z over here and Z is up, so the Z axis points upwards? That is because the curved circle we have is lying on the floor, and this is the orientation it has, and this is what Blender does to it if we move it up. So if we move it up, it does this, and suddenly there is an offset introduced because it's offset from the curve. So imagine the like how the curve gets turned into a mesh. It depends on the offset of the curve to the world origin. So what we do, what we want to do instead of moving this in any way, we want to rotate it. And since we already figured that the curve is actually, or the circle is actually lying down, we want to rotate it, viewing it from above. So we want to use the Z-axis to rotate it. And we want to rotate it by 45 degrees, because it's now sitting on its, like point and not on the face. So we rotate it, and now this is square. And you may say like, oh, I don't really like this because how the edges look so round. We can fix that by adding a split edges node. Here. And that splits all the edges of the input geometry and outputs like this split version. And you may say, yeah, well, this is better than before. Maybe I should change the stochasticity so we can see the edges a bit more pronounced. you may say like, okay, this edge right here is good, but this isn't. There's also an alternative, but I will keep it like this for now. We can fix that or improve that later. What I want to do now is I want to have posts. So the railings actually have something they can sit on. And I want to do it by... Actually, we don't need the second mesh to come. We can just do this. Oh, sorry. I made a mistake. We use this for the railings, because these two are joined together, and this is something entirely different. Sorry, my mistake. Posts, yeah. What the curve output does, something interesting it does, is you end up with a lot of points that are connected by edges, and you can actually look into this control point info tab, like here. I'm not sure what it's called in Blender internally. But you can see that there are 112 control points, and one control point is like right there, and all of these together add up to 112 control points. And we can use these control points to place things on them, and that is called instancing. And we have an instance on points node, and that does exactly what we want. So I would just use this curve as an input for the points, and use another primitive object like a cube for the instance, and join this up with the rest over here. And now you can see this is exactly what I said it would do. Places these cubes on each point. And you may say, oh well, the cube is too large. That's something we can fix, of course. If we want to have it 1 meter tall, because our railing is in fact 1 meter tall. And maybe like 10 centimeters in X and Y. And the origin of the cube is in its middle, so we want to move it up by 0.5 meter. So we can use another transform node. We don't want to rotate it, but we want to move it up by 0 point. And now we have the fence. And I must admit, this fence looks really, really ugly. And that's for a couple of reasons. First of all, this post maybe a little bit big still. Maybe make the beams a bit smaller. You could also use round beams instead. Instead of using cube, you could use a primitive cylinder. That might look better. But also one thing that looks really ugly is how the posts aren't oriented in the direction of the curve. So this cube is exactly oriented the same as this, despite the fence going in a completely different direction. And we can change that by changing how the rotation is set. So if we go into here, we can just change the rotation and see, now it fits. But the problem is that changes the rotation for all beams, and that does not really help us. What we can do though, is we can generate the correct rotation for each cube, or each instance, let's just say instance. Each instance cube. And we can use align Euler to vector node, plug that into the rotation, and that will screw things up probably. Yes, that makes it worse, but we have to make it a little worse before it gets better. And then we can use the normal of the curve. And the normal vector, so this purple thing right here indicates that we are using a vector. The green point means we are using geometry. And this selection we had earlier, this pink color, that means it's a boolean, so it's a yes or no type of situation. And a normal vector, yeah, as you may or may not know, normal means the direction the point is pointing. So normal information is used to make this appear smooth. If I set to shade flat, you can see again how we have these hard edges, and that's because the normal information of each point is used to shade the surface. And here we have a vector pointing straight up away from the face on each point. So effectively we have 4 vectors on each point, because there's one vector for this face, one for this, one for this, one for this, and they each point in a slightly different direction because the faces are oriented in a slightly different direction. And if we shade this smooth, so if I right click and press shade smooth, what that does is it like fuses these vectors together so they point in the average direction of these 4 faces, and that blends their shading color together. Let's say it like that. So this is what the normal does on surfaces or points on mesh objects. In curves it does something a little different. It's not used for shading, but to indicate what direction, maybe let's say, is up on a curve, or is in this case sideways on a curve. So the normal vector, I think, by default points to the sides from curves. So that would mean that like right here it would point like in this direction, and right here it would point in this direction. Right here it would point in this direction. And we can use that information to orient these cubes. So we can put that into this normal output into the vector. And as you can see, that already did something, and it already did what we wanted to do. It orients these cubes, beams, whatever you want to call them now, so that they are oriented in a way that they would be oriented in a fence. Now, this fence looks a little dense. We have a lot of posts, so we end up with these square holes in between. It looks more like, I don't know, it does not... What is going on here? Huh? Interesting. Something weird is going on here and there as well. We can fix that later. I think I know the reason why it behaves like this, but we can fix it. Yeah, it does some weird stuff. It works for the most part. Like I said, we can fix it. What I want to work on right now is spacing these posts out a little better and a little more evenly. Because the thing is, the post spacing right now depends on how dense the mesh is. So if we go back into this wireframe mode, you can see that right here it is really dense, so the posts are really dense together, and right here it's not nearly as dense, so the posts are quite a bit far away. And we can even that spacing out by resampling the curve that we have. So I'm going to add a resample curve node, and I'm going to add it to I think I'm going to change up how this works a little. I want to actually use a mesh to curve first. And then I want to resample. Then I want to use that to transform it. So this is now looking a little weird. Let me move these nodes around. And you can already see stuff changing up here. And before we get to bed, let me just tidy this up a little bit. What is the problem here? Oh yeah, we don't need another mesh to curve here. We can just do this. I think Blender is happy with all the nodes right now. We can just move this setup a little bit further down here and collapse this, because we don't need to work on it right now. That can help clean up the node networks. There are also other things you can do to make it easier to see what's going on in the nodes, but it's a bit too off topic now. Alright, so what this resample curve node just did is reduce every curve with this input into 10 points. So this looks quite normal still because it uses 10 points. This doesn't, especially right here. This looks like a straight line. Actually isn't. It's a coincidence, but this looks like it's one continuous line. It just happens to be that the distance from here to there is the same as like this distance from there to there to there to there. What we can do more than just use the count. We can switch from count to evaluated and also to length. Evaluated just uses points that are already there, so I'm not sure what this what you would ever use this for. But we can also use length, and the default length is 0.1 meters. Let's change this to like 1.5, and now we have a pretty even. Or what was it? Not pretty even. It is evenly spaced, and it looks much better. Just look at this in the usual normal view, and you can see that because we reduced the smoothness of the fence, let's say, this gets quite. It forms a gap right here, so maybe we just want to reduce the amount of subdivision from the previous modifier. Oh, that does not make it better. We could use this resample curve just for the posts, so maybe I just plug this into this and this again, so that remains smooth to there as well. And maybe I'm just going to use that for the posts, and I think that looks good as well. Yeah, that looks a bit better actually. Yeah, so this is a really simple fence. Let's fix up some of the problems we have. First of all, this orientation of the posts right here. One problem I think that we have is that there are vectors that are normal vectors that are pointing slightly upwards in some direction. And that's a bit weird, but we can use path force. First of all, we can just use the z-axis to rotate. Oh, I think that might have actually fixed it already. Yeah. Sometimes you just want to rotate around one specific axis, and that's it. My first idea was to split off the vertical component, and so you can do that by using vector, combine vector, and vector separate, and just plug the normal into here and just plug the x and y into there, so you throw away the z component, and you can enter a value here, or you have to enter a value there, so even if you don't change it, 0 is what is used for the z-axis. And I think that should have the same effect as just keeping it on auto. Yeah, but this also works, so this is fine in this case. And the cool thing is, if we go back into edit mode and say, oh, I want to change this path layout, maybe this is a bit too tall. Oh, I want to make this flatter. Maybe I want to make like a small arch bridge, something. Yeah, so you can do something like this. And you can just add onto your path network, and you will always have a nice fence around everything without really having to put more thought into the whole thing. I think this turned out great, but let's say you don't want to imprison your guests, because as you may realize, there is no open end. You don't really have access to this area. So what we can do is we can choose certain edges to not be included into this curve, mesh to curve thing. So we can add another condition to this selection, and we can do it by using a Boolean map. And that takes one Boolean and another. And now everything will go away because this is an add condition, and this is only true if both inputs are true. So this is if it is checked, it works, and if it is not checked, it doesn't. We want a way to basically choose where to open the path, and we can do that by accessing accessing a value that's in geometry and read and named attribute. And what we want to do is find a way to access the edge crease. Maybe if we connect it. Is edge crease no longer something that Blender inputs into geometry nodes? It would be quite unfortunate. Huh, that's really weird. Is there another way to access edge crease? I'm not sure actually. Let's just go in here and crease an edge. To modeling, it's a bit easier to see. Maybe we want to have this end open. Maybe this leads to a station or something. We can go into edge and edge crease and increase it, and you can see the crease value on the top left. If I drag my mouse all the way in one direction, it is kept at 1, and if I keep it at 1, we should be able to access this, shouldn't we? Oh yeah. Now that we have one edge creased, now edge crease is an attribute we can access. And suddenly you can see we have a fence right here, but we want the opposite. We want the fence to be nowhere if we have an edge crease. So we can add another Boolean magnet. We can actually just duplicate this and change this to not. Plug this in there and this in there. And now we have the exact opposite. We have an open-ended path. And that's basically what I do when I work with paths. There's something weird going on here. What's going on here? Is this? Oh yeah, there were some duplicated points there. So just as an example, I can just select this edge, go into edge crease, increase it, and now it's gone. Maybe I can crease these edges too. And now this completely ends. Interesting. Yeah. All right, but there are more things we can do to improve this whole thing. Let's say we want something more fancy than just effectively stretched cubes, or squished cubes rather. We want to make our own post. And now we get a bit into modeling territory. Let me just make something real quick. We have a cylinder here, and I'm just going to scale it down so it's just 1 meter tall, because that's everything we need. Maybe a little bit taller. We could make it a little taller. And I want to decrease its diameter a bit, and move this part up, and down a bit, and make it much larger. So we have a bit of a base, and maybe move this down. Maybe make this a bit larger. Oops, there. Maybe make something like this. Maybe shape this smooth. And now we can use this object to use for our post. And we just need to go back into the geometry node setup, and we have this right here. We no longer need that because we now have our post. Which I could post in here and instance that, and now we have a nice looking post. And I think that looks quite good. And now maybe let's finally just fix the hard edges down there. It was this setup right here with the split edges. What we can do instead of split edges is just split the edges that have a really sharp angle. And that's something we can read similarly to the edge neighbors. We can read the edge angle, And we can take another compare node. We can just steal it from over there. Signed and unsigned angle does not make a difference here. Unsigned angle is basically just the angle between two faces without considering what side of the face is up or down. Unsigned angle considers the angle between the both upsides from the face. So in this case, this does not matter. So if we have an angle of 1, we want it smooth, but 1 is not really helpful. We want it at 90 degrees, but 90 degrees does not really do anything in this case. I think what I forgot is that this is in radians and not in degrees. So we need to use a math node that is degrees to versus to radians. So we can put in degrees, put in 90, and this here. And maybe instead of saying we want it to be exactly 90, we can also use greater than maybe like 85 or something. And this does exactly what we want. That keeps these edges smooth, but it splits these edges up here. And that's basically how I approach every fence. There are some nuances, like you can be more creative with this. You can do more things, like if let's say you want to enforce a square end, and you want or maybe not just an end, but maybe you want this to be exactly square, and that's something you can do, but the even spacing of a post does not always guarantee that you have a post in each edge. And there are ways to do exactly that, to enforce the post to appear in each edge and to distribute along each edge the rest of the posts evenly, so that it doesn't look weird. But this is what I do when it comes to fences. I think this works. And like I said, it is really easily adaptable. So let's say we want to connect these two areas, like these 4 points, and if I just press F, all these fences in here will vanish and there will be a new fence right here. And that's the magic of it. You no longer have to think about how you model the fence. It will adapt to your path. Yes. Okay, so thanks for watching. This is probably really long, and I'm sorry for the length, but I feel like explaining it like this, with showing like little extra things here and there, might be really helpful as an introduction or as an entry-level project to make something actually useful for impact building in Blender. So it's not just like, with the geometry nodes you can do this simple thing, but that simple thing just does not really do anything useful for you, but something like a fence generator does. Yeah, feel free to use this setup for your own modeling. There's nothing really that special about it. Have fun with it. Like, tell me if you use it anywhere. I'm really excited to see results. Alright, thanks for watching and bye bye.